In a computer science lesson today, I introduced some students to digital forensics through Capture the Flag challenges. So we walked through the first couple of steps of this challenge on CTF Learn. The idea of digital forensics is that you have to try and extract or recover some data from some hidden files or some encrypted files or some corrupted files. And on CTF Learn, you're looking for flags, which are just a series of text, often in the format CTF Learn and then some moustache brackets, but not always. So in this particular challenge, we have a PNG file and image, which I've downloaded and is in this folder here. Today in lessons, we solved the first couple of challenges in Windows using online tools, but some students were interested in how we could use Linux, especially Kali Linux, to do that. So this is Kali Linux running in a virtual machine, and I'll talk you through how you can do most of the challenges in the command line. So if we want to find out about that file, we can use the file command. It's recognized that it's a valid PNG image. We've got the width and the height, and we should be able to see that image here. And there's likely to be some data hidden in there. So for Capture the Flag, it could be steganography, it could be hidden inside the alpha channel, it could be in the metadata, it could be concatenated onto the end of the file, all sorts of different things that we could look for. Let's see if we can find out anything about the metadata. Using EXIF tool, it has given us a warning that tells us that there's some more data at the end of the file. So let's extract that. Let's use binwalk to identify what's there. This will go through all of the binary data, and it's found not just the PNG image data that we can see. There's an archive file. It's a bit like a zip file, but using a different algorithm for the compression. We haven't got that file yet. We need to extract it using the extract option. Then it should create a folder for us. Let's go inside that folder and pressing tab to autocomplete ls to list. So we've now got a RAR archive and we've got an MP3 file. So the RAR archive, if we take a look at that first, it doesn't look valid. It's just binary data. There's something wrong with that file. So we'll come back to that later. The MP3 file, if we look at that, it has detected it's a valid MP3 file. Is there any metadata that we can use to find out about it? There's some metadata here that says, is there a password here? That's interesting. So let's open the file and see what it looks like. So if I play it, sounds, I don't know if you can hear it in the video recording, sounds like a cat purring, but with all sorts of nasty interference going on there. We can see the waveform as in amplitude over time, but if we view it instead with frequencies over time, high frequency to low frequency, it looks like some of that cat purring sound has been replaced from about 5 kilohertz up to about 8 kilohertz. Let's zoom in on that and see. I think that's so clever. I don't know how they've done that. They've taken some text, converted it to an image, and they've put that image as a spectrogram so that it's encoded over time horizontally and in terms of frequencies on the left and right channel of that audio. So we want that probably as a password. I suspect that password will unzip this, but we can't unzip it yet. I shouldn't say zip, it's not a zip file. If we try, it's going to say it's an invalid archive. If we look at the file in a hex editor, it's a small file. It looks like there's a text file encrypted inside, but we can't access when we can see the data, but it's encrypted. We know the password, but we can't extract it yet because it's invalid. And you'll notice it says cat as the first 3 letters here. If we look at what a RAR archive is supposed to look like, the file header, where's the editor gone? should start in hex with 526172. So if we put that in as hex, 52 is a capital R, not a capital C. 61 is correct, that's a lowercase a. But instead of 74, we want 72. So it should say ra and then an exclamation mark. Yeah, we want that exclamation mark. And then some extra data, and then it will tell us how long the data is and all of the file names, and then it will start the encrypted data. Right, let's save that, close it. This time, hopefully, what's the file called? Begins with lowercase y. Yeah, good. It doesn't just say data this time. It's detected that it is a valid archive, and we should be able to extract it. And we need to put the password in. Let's get the password from Audacity. Be careful with capital letters and numbers here. Great, it's extracted it. So we have a text file. Let's see the contents of that text file. And this looks like some base64 encoded text here. So let's echo that to the screen. You can see I've done this before. If we just echo it to the screen, we see that base64 encoded data. It's just a way of putting binary data into kind of ASCII characters. Base64 means you've got lowercase letters, uppercase letters, numbers, and some punctuation, but not all the non-printable characters that are included in ASCII. If we echo that and pipe the output through a base64 decoder, then you get your flag. I'm not going to include that in the video. You're going to have to do that yourself if you want the flag. But hopefully it's an introduction to capture the flag activities, little bit of an overview into the idea of digital forensics, recovering data, extracting data, hiding data, finding data, puzzles, within algorithms, within files. It's a whole world of computational logic to discover that can lead to some pretty lucrative careers if you can get your head around this. So all the best. Let me know how you get on.